Good morning, Year 12, or afternoon, whatever time you're watching this video in. This YouTube clip, I'm going to go through exercise 105, the sum of a geometric series. Now, normally when I teach this, I used to only teach one of these formulas that they give us here. But because you get both of these on the formula sheet, you may as well learn both of them, or you get used to using both of them. They are actually the same thing. They're the same formula. But because, and they list them here, because they think that you're going to find it hard to deal with negatives, when r is a fraction between 1 and minus 1, what happens when you plug it into this formula, you get negatives. And they just think you can't deal with negatives, but you do. You use your calculator. So seriously, there's no point in if you were, when I used to teach it with, before they had a formula sheet, I said just remember that formula, because when you plug them in, they do exactly the same thing. They do exactly the same thing. All right. So we've got two formulas. This one is for when r is greater than 1 or minus 1. It's not a fraction. And this one, when you've got a fraction between that's not bigger than 1. Now the proof for it. Now I'm just going to go through Margaret's because she does a pretty good proof here. So what does she do? So we've got our series, as you can see here. And if we multiply both sides, and she's written it here, when you multiply both sides by r, you then get these two, or this one. Remember, this is still RSN here. Now, here's equation number 1, here's equation number 2. Now, when we subtract those, and we're going to do this one minus this one. So here, you get this RSN minus that. You can see that there. And when I minus this other stuff here, watch what happens. Watch what happens. I'm just clearing it so you can see it. So remember, I'm minusing this minus this. So that goes with that. That goes with that. That goes with that. And here you'd have another term, ARN minus 1, and that goes with that. So the only two terms you're left with are this one and this one. And remember, you're minusing this one minusing this one. So it becomes this minus this. So then what do? So you've got to here, you've got r, so you take the Sn out, you get r minus 1, you take the a out, you factor that out, and you get divide by the r minus 1, and there's the formula. Pretty easy, very neat. And if you did the subtraction the other way, you get that formula. And it doesn't matter, they're both the same formula. So how do we use this now? So some of you have already skipped ahead and you're doing this, and it's quite easy, but I'm going to do a couple. So remember, S of n, our two forms, S of n equals a, what is it, 1 minus r, a outside of r n to the minus 1, n to the minus 1, and r minus 1. And the other one, you just swap them around, a 1 minus r to the n over 1 minus r, which is the one that I always used to use. So let's have a go. First one, so we're finding S of 10. So this is question 1. And our a is 6. Our r is 24 divided by 6, so it's 4. 1 minus 4 to the 10 over, using the wrong one, 4 to the 10 minus 1 over 4 minus 1. And again, you get your calculator out and you do this. It's all one big fraction. 6 times 4 to the 10. Silly. 4 to the 10 minus 1 all over 4 minus 1. I know that's 3, but I'm writing it in anyway because I'm just going to go and change these things from now on. And I'll just get the answers up. And that's right. 2097150. And you notice that these are going to get very big because they're geometric series, so they get very big very quickly. I'm not going to bother with any of with B there, but what I'm going to do with question 2, it's a negative, so let's do 2a. So that was 1a. And what do we got? We're finding S of 8. S of 8. What's my first term? Negative 1. What's my common ratio? 7 divided by negative 1 is negative 7. So I'm going to put negative 7 in brackets. Now this is important because this is going to be, your negative is going to be multiplied by itself an even number of times. 8 minus 1. But on the bottom, I've got negative 7 minus 1. And you're going to see that these two negatives here will cancel out, but we'll do it anyway. So now once I've got my calculator like that, I just go back and I just change everything. Oh, come on. So, negative 7. Negative 1, sorry. Better put this in parentheses. Negative 7 to the power of 8. And then I've got negative 7 minus 1. And that's the answer. 720,600. All right. So most of these are just a case of plugging them in the formula. So 1, 2, and 3, pretty easy. Let's have a look at what they're doing in question 4. And remember, you've got to do all these. You need to get practice at them. So question 4. Well, they don't tell us how many terms there are. So my suggestion would be to find what that term is. All right. And once you find that term, you can find the sum. I wonder if that's how she did it. Let's have a look at, because I don't usually bother looking at these. Find the sum of the first terms, evaluate that B. Yeah, so you can see she's finding what term it is. All right. All right. What did she do then? Did she? Oh, so it's down here. Yep, so she finds a term. There it is. Righto. So, what do we got? And I like the idea of writing this all out. So 4a, what are we finding? We don't know yet because we've got to find the number of terms. But we've got a, and that a equals 2. R equals 10 over 2, so R equals 5. And we've got T of n equals 6250. Now you could go along on your calculator and see how many times you'd have to go 2 to the power, 2 times 5 and 5 to the power of whatever, how many times you'd have to do it to get there to get the term. But we are going to use a formula. So A R to the n minus 1 equals 6250. So that's 2 times 5 to the power of n minus 1 equals 6250. divide by 2, 5 to the n minus 1, 6250, 6250 divided by 2, 3125. Now I know this has got to be an exact term. I could just go to my calculator and go 5 to the power and see how many times I had to press it before I got 3125. It wouldn't be too many because these things get big very quickly. But I'm going to use my log laws. Now, remember, the textbook and many other textbooks will say take the log of both sides, but I always use this, y equals a to the x, and I just go, well, that means x equals log a y. So I get n minus 1 equals log 5, 3, 1, 2, 5. And then I can just use any log I want. I prefer to use ln, the natural log, 3, 1, 2, 5 over ln 5. So ln 3, 1, 2, 5, oops, too many 2's, divided by ln 5. I've got too many brackets there. I get 5. So n minus 1 equals 5. Therefore, n equals 6. What was that? Now, we haven't found the sum. So we're finding s of 6. So our a is 2. Our r is 5 to the 6 minus 1 over 5 minus 1. So again, 2 times 5 to the power of 6 minus 1 all over, I'm just going to go 4, if that's okay. 7812, and that's the answer. All right. Most of these will be the same. They'll all be the same. Here, doesn't matter, you're going to have a negative. Here, find the ninth term. That's easy. It's t of 9. You got a, you got r. That's quite easy. Find the sum of the first 30 terms here. I might do this one because it's got a decimal in it, but it's not that hard. So I'll do 6 and 9 and then 12. 6, 9 and 12. And if you're having any problems, just email me. You shouldn't. This is relatively easy. So have a go at them yourself and then come back because you should be okay with them now. So here's 6. And A equals 1.09. R also equals 1.09. And what are we going to find? 30 terms. S of 30 equals 1.09 times 1.09 to the power of 30 minus 1 all over 1.09 minus 1. Okay, bang, it's just calculator work. So I'm just going to set it up again. I'm not going to bother going back. 1.09, I forgot the point, 0.09 times 1.09 to the power of 30 minus 1 over 1.09 minus 1. What are we doing? 148, what are we going to? 2 decimal places, 148.58. 148.58. Approximate because we've rounded off. And that's right. Question 9. This is a good one because we have to use the second formula. You don't have to, but I'm going to use the second formula because my R is a fraction between less than 1. So here we go, 9. Again, always write down all the stuff. A equals a half. Now I know it's a half, but I'm just going to show you a quarter divided by a half. Do that on your calculator and you'll get a half. And T of n equals, S of n. S of n equals 1023 and 1024. So, going to use the second formula now. And you just swap the r and the 1. So, S of n equals a 1 minus r to the n on 1 minus r. That's the one we're going to use. So 1023 on 1024 equals a half, 1 minus a half to the power of n, which we don't know, 1 minus a half. So 1023, 1024 gives me a half, 1 minus a half to the n. What's going to happen to those halves? They're going to cancel each other out. Well, that's good, because that was going to be tricky to deal with. 1023, 1024 equals 1 minus a half to the n. Now what I'm going to do, I know that you guys are used to negatives, but I'm just going to take that, add it over here, and so you'll see, so I get a half n plus 1023, 1024, because I added that minus a half n over. It's a half to the n, come on. And I've got 1 on this side. Now I'm going to subtract this. Half to the n. Now that's almost a whole fraction. That's 1. You can do it on your calculator, but you should be able to go, that's just going to be 1 over 1024. Oops, that looks like a power there. Now I'm going to use logs to solve this, a half to the n. But you should be able to go, and I can use it as a fractional log, but a half to the power of n is 1 to the n over 2 to the n equals 1 over 1024. So essentially I'm just going to be solving this bit here. 2 to the n equals 1 over 24. But I'm going to do it like a log for the whole thing, and it'll just pop out the same. So remember our log law, so that means n is going to equal log of a half of 1 over 1024, which is n equals ln 1 over 1024 divided by ln of a half. So just go to my calculator, ln 1 divided by 1024 divided by ln 1 divided by 2. 10. So n equals 10. I'll just double check. I just got to get my solutions up. What is that? 10 terms. The 10th term. Beautiful. All right, so you should be finding these reasonably easy. If you're having any problems, someone has asked about question 12, and it is a little tricky, but let's have a look at it nonetheless. Righto. Now, they've given us two series here. And even though, all right, well, I'll just wait till I get them up. All right, that should be enough space. Okay, find the sum of the first 10 terms of this series. Oh, so 12a is pretty easy, 12a. And what have I got? A equals 2 and R equals 2. So S of 10 equals 2 to the 10 minus 1 over 2 minus 1. That's going to be pretty easy. Pump it into your calculator. 2 times 2 to the power of 10 minus 1 all over 2 minus 1, which is just 1. 2046. And then in B, got to do S of 10 of the next one. Well, let's have a look. A is 1, but you need to have a good look at this. This is not a geometric series. It's an arithmetic series. It's going up by 2. It's the sum of the odd numbers. So we don't have a common ratio. We have a common difference. So D equals 2. Okay, so now I have to use this. S of 10 equals 2a plus n minus 1 times d, n over 2. So 10 over 2, 2 times 1 plus 10 minus 1 times 2. Now I can put that all in my calculator, but let's be a bit smarter. 5, 2 plus 9 times 2, 18. That's going to be 20. 5 20s. Halve it and add a 0, 100. So that's it. That's why I think some people found this difficult, because they've hidden an arithmetic series in a geometric exercise. But you've got to be wise enough to pick that. So what are we doing in C? And this is even trickier. So C, what do we got? 3 plus 7 plus 13. They should give us a few more, plus ... Well, let's have a look at this. 3, well, 3 is 1 plus 2. 7 is 3 plus 4. 13 is 5 and 8. Oh, look at this. This is the arithmetic series and this is the geometric series. They've combined them both into two series. We've already found S of 10 of this. It's 100. We've already found S of 10 of this. It's 2046. So therefore, S of 10 of both of them is 100 plus 2046, 2146. So that was a tricky one where they combined a geometric series and an arithmetic series. So hopefully you're keeping on track with the work. Remember, email me if you're having trouble.